Hi everyone, my name is Rutuja and welcome back to Data to Crunch, where we deep dive into data analysis, data engineering, and business intelligence. So, in today's video, we are going to walk through a detailed PySpark tutorial where we will try to perform some multiple transformations and operations on a particular dataset. So, in this video, I'll guide you step by step to understand the essential PySpark techniques. So, let's dive into it. If we'll go through our agenda, it looks like first we'll try to understand our data set, then we'll try to perform data ingestion, followed by how we can read the data, then how we can perform data cleaning and transformation on our particular data set, and lastly we'll try to see how we can export that data. So now let's try to understand our data set. Let's have a quick overview about our dataset. So I have taken this dataset from the Kaggle and it is about the HR analytics. So basically there is a company which is active in big data and data science who wants to hire some data scientists amongst the people who had successfully passed some of the courses which are conducted by that respective company. So many people have signed up for their training and now company wants to know which one of these candidates are really interested to work with their company even after the training, or they are just looking for the new employment because it will help them to reduce the cost and time, as well as they can improve their training and planning of the courses. As along with that, they can improve the categorization of the candidates. So this data set basically contains 14 columns and almost 19,000 records. So roughly we can say that this data set contains the information related to the demographics, their respective education, then experiences who are of that and candidates who are signing up and doing the enrollments. So this is how our data set looks like. So now let's have some data cleaning and data transformation on this data set. So I have logged into my Databricks platform. So the first thing first, go to the compute and create the compute first so that we can connect our work with the active cluster. So just click on create compute, select the Databricks runtime version, whichever you want to select. So right now I'll go with the by default which has given by the Databricks and just click on create compute. So we can see that it is still in the progress and it will get connected, but it will take some time to get connected. So let's just wait till this cluster gets started. Okay, so now we are connected to our cluster. Now the second important thing is about the data ingestion. So you need to ingest or you need to upload your data to this Databricks platform. So for that sake, just go to the catalog and here we will create a table. So click on create table and browse your respective file here. So this is my file. I'll just open the file and then it will give you one statement. File has been uploaded to one of the respective path. So either you can note down this path and even if you forget, then we can also fetch this data via our coding. So you just don't worry about it. Now the third step is go to the workspace and create a Python notebook there. So it's always a good practice to first create a folder and in that you can create your respective Python file. So you can click on create folder. You can give the name whichever you want to give. Create. So once you will create a folder, in that folder create a notebook. So this will be my empty notebook. So first, good practice, rename your notebook. And once you rename your notebook, just connect to your active cluster. So this is my active cluster which I have created. So I'll connect to that. And now our notebook is ready and we can start performing our programming here. Okay, so now we are going to use PySpark, right? So a PySpark is, I can say that it's nothing but a Python API for the Apache Spark, because Apache Spark is an open source distributed computing framework which is designed for big data processing analytics, right? So PySpark, it will allow you to leverage this Spark's scalability and inbuilt memory processing and also machine learning capabilities using Python. So basically it will make an excellent tool for the data analysis and engineering using this PySpark. So for this, we'll keep Python as our default language. Now, the first thing first, I always personally prefer to import all the functions and the types of the PySpark to avoid the errors afterwards. So to import these functions, what we can do is like we can write a command as from PySpark.sql.functions and then import. I want to import all the functions, so I'll place star over here, and then also I want to import all the types also. So PySpark dot SQL dot types and then import all the types. And then just run this command by shift enter, or you have the option to run the cell from here, and for the to run the whole Python notebook you have run all option here. So I'll just do shift enter. Okay, so now our all functions and types has been imported. So now next thing will be dataset reading. So I always prefer to put good markdowns also for the better readability. So you can change this Python to markdown for this respective cell, or you can do %md also. So once you will write %md, this will automatically will get changed to markdown. So %md and highlight dataset reading. Okay, fine. So now we want to read the data, right? So for that we have command as spark dot read dot, then we need to enter our respective file format. So right now we know that our format is .csv, right? Okay, so before this, what we can do is like I'll just click on this plus code. So let's say suppose you have forgotten that path where we have uploaded our respective file, right? So what you can do is like you have one command as dbutils.fs.ls, and here you need to give your respective path of file store. So in inverted commas or double inverted commas, I'll write file store and then tables, and then just run this file or run this command, and you can see that it will give you the results, and it will give you all the files right which are right now has been uploaded to our file store in the table format. So if we check if our file, then yes, we can see that whichever file which we have uploaded, that is here, and it has been uploaded successfully, and that is into .csv format, right? So here spark.read.format into inverted commas, we need to state that okay, our file is into .csv format. So after this you need to do option as infer schema as true. So this option states that Databricks will automatically detect the respective data types of that respective columns of that file which we are going to upload. So you can also give your data types manually also, but it's we have this option ready, right, for the data which has given by the Databricks. So I'm opting for this option, and then again option, and I want to set the headers also, because if you will not set this header, what will happen that your columns will come as a first row. So for this I need to do header as true, and then load, and we need to give our respective path here. So our file was file store. Okay, I'll just copy paste this, and this is the command to read our respective data set, and once we read it, we need to store this data set into a data frame so that we can work on that data frame and we can perform some transformations on that data frame. So I would like to give that data frame name as df, and once I'll give that data frame, I would want to display that data frame also. So let's now check if it is working or not. Okay, so now we can see that infer schema is equal to true. That concluded to it has automatically detected enrollment ID as number int, then city as string, then development as double, gender as string, and so on. And it has automatically detected, and it has been giving header format properly. So let's say suppose if I'll do this false, Now let's check what happens here. So if you can see, we have given header as false, right? So it has taken by default C0, C1, C2 as headers, and the actual headers which we want that are coming as a first row. So to just avoid it, we usually prefer header as true option here, and we just display it. So usually what happens is that df.display, this format will give you your dataset or the result into correct tabular format. So you have one more option also, df.show. So you can see the difference clearly, right? So df.show, it is giving you the result, but that is not getting displayed into correct tabular format, and we are not able to know what is exactly here going on, right? So usually we prefer df.display, so it will give you a correct tabular format and it will be easier for you to read this data. So let's say suppose next I want to check the schema, or like if I want to check like, okay, I need to check that if Databricks has given the correct schema or data type for that particular column, right? So what I can do is like I can say df.print schema and round brackets and just shift enter. So now here it is giving me all the column names with their respective data types. So enrollment ID into integer, then training hours are into integer, then relevant experience is into string. So this is for better practice, or if you would like to check how many columns are there into your data set and what are their respective data types. So usually we prefer df.print schema here. So now we'll see how we can rename the column names. So let's say suppose we have this column name as gender, right? So we will change this column name to employee gender. And let's say suppose I want to rename one more column. So we have this company size column name, right? So I would like to change it to company employee count. So it's just for the better readability practice. So if you would like to change the column names, so I'll put a markdown as rename column name. Okay, so now let's start with our coding for this. So our data frame is df, right? So df dot, and now I want to perform some transformation on this. So to rename the column name, we have command as with column renamed. So I'll just click on this command and then round brackets, and here I want what I want. So I want my gender column name to be changed as employee gender. So this is the syntax for this, with column renamed, then give the existing column name, comma, and then give the new column name which you want to give. And suppose, let's say suppose I want to rename one more column, right? So for this sake, what you can do is like with again dot with column renamed, and then give the next column name which you want to change. So let's say suppose I want to change company size column name to company employee count. So this you can write it in this way, and let's say suppose you want to increase some readability, right? So what you can do is like you can just simply take it down, and here you can give this slanting line. So once you will change this column name, I would want to assign this changed column name to my data frame. And once you will change this column name into my data frame, I would want to display my data frame. So for that, what I can do is like df.display and then round brackets and shift enter. So now let's check. Okay, so now our column name gender has been changed to employee gender, and then just check. Okay, company size has been changed to company employee count. So we have started with the data transformation, right? So I'll just put a markdown of data transformation here, shift and enter. So the next transformation would be on relevant experience. So we can see that we have entries as has relevant experience, no relevant experience. So what let's say suppose what we can do is like we need to convert this relevant experience to a one column which will be numeric. So in that column what we can do is like if we have entry of has relevant experience, then we will mark 1 in that column. And let's say suppose we have no relevant experience value here, then we will put value at 0 in that respective numeric column. So for this what we can do is first we'll perform our data transformation on our data frame, right? So our data frame is df dot. Then for this we have one command as with column. So this with column, it will add one new column, or it will update the existing one. So right now we have decided to create new column, right? So the new column name which will we will give it here. So let's say suppose our I want name as relevant experience in numeric. So this is my new column name. So Databricks will automatically take it as a new column because it will not find this column name into existing column. So with column, if you want to perform some transformation on your existing column and you want to change the existing column, then you can give that respective existing column name here. But right now I want a new column name, so I have given that new column name. And then comma, and for this sec we can use when command. So when is nothing but a conditional command that works as a if else statement which we use in a SQL, right? So if that particular situation or current condition is true, then give me this value, or otherwise assign this value. So how it will work in our situation? So if I have has relevant experience in that column name, then it will then assign one value into my new column, or else or otherwise in that otherwise it will this no relevant experience it will take it as otherwise. So if that entry is otherwise, then I would want to assign 0 to that respective column. So this is how when otherwise function works. So here we will try to use that function. So when, then round brackets, and the when that relevant experience is equal to has relevant experience, right? So for this I would like to take column. So for that I have col as command. So I would like to take column, and then which column? This relevant experience column. So in this I'll put that column name if relevant experience is equal to what experience we want, has relevant experience. If that text contains has relevant experience, then I would like to assign a value as 1, right? So if you as we want to assign 1 and 0 numeric constant values there, right? So for this you need to use lit function, lit, because it will create a literal value that can be used in a Databricks or data frame operations. So for this what we can do is like comma and then assign the value as 1. Okay, so if we want to create one new column, relevant experience numeric, and in this we will use existing column which is relevant experience. If that column contains a value of has relevant experience, then I would want to assign one value into my newly created column. And if not, then what? Then I would like to assign 0. So for that we are using when otherwise command, right? So when is completed, then dot otherwise. If otherwise, then I would like to assign 0. Then again literal values. So for this also again I need to use lit and then assign 0 value to it. So once it has been done, then change my existing data frame and assign these changed values to my data frame, and then I would like to display my data frame. Let's see if it works or not. Okay, so we are getting some output. Now let's just check if we are getting relevant or not. So we can see that our new column has been added as relevant experience numeric. Then if our value is has relevant experience, then it should be 1. Okay, fine, we are getting it. And then if we have no relevant experience, then it should be 0. So okay, we are getting as expected values. So in this statement, or in this command, we have used dot with column to add new column with when and otherwise statement, which gets treated as if and else statement. So now we can perform transactions on existing columns, or we can change the values in that particular column only. So for that sake, what we can do is like, so let's say suppose we have this city column, right? And it has entry as city underscore 41, 103, and so on. So the basic pattern they are following is some string underscore and then the value. So I want to change this column in what I can do is like I can just remove this city underscore, and I just can keep these values here, because city and underscore, it is redundant and it's of no use. So by doing this, we can check that how we can change the entries in the existing columns without creating new column. So for that sake, what we can do is, this is our data frame df, right? So for this also we will use with column command, and then the column name would be city. So on this city column name, I want to do some transformations. So comma, and then I'll put a condition or that particular transformation. So my transformation would be regex replace. So with this, what we will do is like we will just replace this city underscore with an empty string. So it will effectively remove that redundant value. So for this, again, we need to enter the column name. So the column, and our column name is city, and in city column, what do you want to change? So that condition would be comma, I want to change city underscore with the empty string. So city underscore, then again comma, and then the empty string. And once you will change it, just update my data frame. So df equal to then this condition, and then just display my data frame. Let's just check if it is working or not. Okay, so now we can see that we are getting expected output city and then 41, 103. So we have basically changed the column values in that column only without creating a new column. So for this also we have used with column, then that column name which we want to change, then we have used this regex replace command, and we have used this command on column city, and then in city column name we want to replace the string city underscore with the blank string. So this is how this syntax looks like, and this is the output. Now let's say you want to handle the missing values. So for that we have the command as dot FillNa. So for this, let's just take this column as employee gender, and we can see that we have some null values here, right? So let's say suppose I want to replace these null values as unknown for this employee gender column. And if I would like to change one more column, suppose for example, along with employee gender, I want to check the education level column also, and here also I have null values. So for these both columns, if you have null values, then replace those null values with the unknown. So what we can do is we have command. So first our data frame would be df dot. So we have syntax or command or API as FillNa. So it will replace all these null values of those both respective columns to unknown as a text, which will be a text. So FillNa, then what? Then please replace my employee underscore gender column with unknown. So for that I'll have this colon, and again the value which I want to give to that null value, and comma, and we have one more column, right? So that would be education level, comma, and then replace it with unknown, and then just change my data frame and display it to me. Okay, now let's check if it is working or not. Okay, what is saying? Okay, I got the error. So right now we are just not changing only one column, right? We are changing the entries for multiple columns. So it needs to be treated as a string. So for that, I need to enter these values into curly braces. So that will get treated as a string. So now let's check again. So we have our output. Now let's just check. We can see with the employee gender column, NA values are replaced with NA, unknown. And then for education level also, we can see that null values are replaced with the unknown. So this query has been executed successfully. That's what we can say. Now let's say I want to create one more data frame, and in that data frame I just want only two columns, and those will be enrollment ID and the city. So I have these the two columns, right? So I want only these two columns into my new data frame, and along with that I want the column name to be displayed as employee ID and work city. So I have two conditions right now, right? So I just want only two columns, and in that two columns I want these column names to be changed with the another requirement or the another values which business wants. So for these two changes, what we can do first, just to select only these two columns, I'll have the command dot select, and in that, to change these column names, I'll use alias. So now we'll see how it works. So I want new data frame, right? So for that, I'll just create one new data frame. Let's say suppose df underscore alias, and in this I want existing data frame I want two column names, so those, and I want to select those column names, so I'll use select command, select, and then which columns I want to select. First one would be column enrollment ID, and I would want to display this column name as employee ID. So dot alias and round brackets, and in that inverted commas I'll give whatever name I want to give. So this will be only for one column, and again for the next column what I can do is like comma and then again column, which column you want, city column I want, and in city with city column please change the alias, please change that column name as work city, and then just display that respective new data frame. So my new data frame is data df alias dot display. Now let's just check if this select and dot alias are working or not. So this will be our output with only two columns selected from the existing data frame into new data frame along with the changed names of that respective columns. So this is how our output looks like. Now let's say business wants to know that how many male employees are there. So for that what we need to do is like we need to use filter command, and with the filter command we want to filter out the male values or the male column values. So we right now we have male, female and unknown values, right? So I just want to filter only male employee gender. So for that what we can do is like I'll just create one new data frame for this. You can change these values into existing also, but for the practice I am just adding new data frame. So the existing data frame is df dot, we have this filter command here, and we want to execute this command on column employee gender, right? So column, then enter your respective column name into inverted commas, and then what should be the value, equal to male. So this will be my filter command, and once this filtering is done I want it to be displayed. So now let's just check if this filter command is working out or not. Okay, so we are getting as expected output into our new data frame. You can use your existing data frame also here, but I have taken new data frame. I've used existing data frame. In that, I'll just filter the column employee gender with male value entries. So I'm getting the result almost 1460 rows which has employee gender as male. Now let's just check the next command, sort, in both ways, in ascending and descending. So for example, this city column, I would like to sort this column first in ascending and then descending way. So for this, what we can write is, suppose I'll create a new data frame. Df sorted is equal to df dot sorted or sort, and which column do you want to sort? That will be city column. So if we'll just say sort, then it will sort in ascending order, and for descending we need to give as .desc. So let's just check first. Ascending, df sorted dot display. Okay, so now it is sorting our city column in ascending way. So now let's just check for descending what we can do. So for descending, simply I'll just change this data frame name, and with df dot sort and then the column name. So for this, we just need little bit changes. So I want to change column and then city column. I want to change. I want to sort, and I want to sort it in descending order. So this will be my syntax: df dot sort on the column city with descending, and then just display. So we can see that now our city column has been sorted in a descending way. So this command is very simple. You just need to use df dot sort. If ascending, then nothing, and then if descending, then .desc. You just need to add it over there. So now the next command would be drop duplicate. So I would like to check all the rows and all the values for all the columns, and if all the values in all the columns are same, then I just want to drop that duplicate. So for that we have command as drop duplicates. So that would be df dot drop duplicates, and I'll just keep the subset value blank. You can enter subset here also if you would like to check the duplicate values only for that respective column, whichever you want to select. But I want this drop duplicates for all my entire data set. So I'll just keep that subset as null. So df dot drop duplicates, and please assign this value to my new subset. So df duplicate is equal to df dot drop duplicates, and then just display it. So let's say check. So earlier we were having 2129 rows, and right now also we are having 2129 rows. So it states that we don't have any duplicates based on all the columns. Next, we will check the string functions. So in string functions, it includes lowercase, uppercase, and Initcap. So by using this, we can manipulate the text into from any respective column. So for example, here, let's say suppose I just want relevant experience column to be displayed, and I just don't want the rest of the information. So to select the particular columns, we can use the select functions, and in that select function, we will try to use these string functions. So let's just first try lowercase function. So our data frame name is df dot. To select any particular column name, we will use select function, and in select function we will use lower, upper, and initcap functions. And in this function, I'll just give the column name on which I want to use this. So here, let's say suppose we want to use this on relevant experience, right? So I'll give that respective column name here. And suppose I want it into new data frame. So I'll just assign new data frame to this syntax, and we will just display this new data frame now using display function. So now let's see how it functions. Now we can see that we are getting only one column, and in this column each and every row is into lowercase. So similarly it goes to the uppercase. So instead of lower, we'll just replace that with upper. So let's just do the minute changes. So I'll just change the new data frame name and this function from lower to upper, and let's just check the output. So now we can see that in this column each and every word has been capitalized and we are getting it into uppercase. So now let's just check for Initcap. So I'll just copy paste the syntax because there are not big changes here. So we'll change the data frame name and the function. And now let's just check the output. Now we can see that in this column for each and every row, new word is starting with uppercase and rest of the information is into lowercase. So this is how we can use these three string functions, which are lower, upper, and Initcap. Now I'll just display my original data frame so that I can check if we can apply any other functions or APIs on that. So this is our original data frame. So let's say suppose we have null value into major discipline column, right? So for example, if I want to drop the rows in which this major discipline is showing null value. So in this data set, what will happen? So for this row or for this entry, major discipline is showing null value, right? So I want to delete this row. So similarly, we'll go with the rest of the information or data set also. So wherever there are null values for the major discipline, I just want to delete those rows. So for that, what we can use, so we can use .DropNa function for this. So our original data frame is df, right? So df, then DropNa. We have this function here. So in DropNa, I just don't want to drop all the values wherever there are null values into entire data set, right? I just want to apply this .na function to any respective column. So here that respective column name is major discipline, right? So for this we need to give a subset. So for DropNa, I'll assign one subset, and subset is equal to into square bracket inverted commas. I just need to give that column name, and I'll assign that column name. So let's say suppose here I'll create a new data frame df.drop, and I'll assign that data frame with major discipline not equal to null values, and I'll just display it. So now let's see our output. So this is df underscore drop dataset, and we'll check our major discipline, and we can see that now it has no null value for that respective column. So whichever entries were there with major discipline is equal to null values, those all records or all rows has been deleted now. Let's say suppose I just don't want any null value in my data frame. So for that I can just use DropNa with any string inside it, so that what we will get, so it will remove the rows that have at least one null value in any column. So the syntax is very same. So we will use this syntax on our original data frame. So df dot again DropNa, and in DropNa I just want to display, if we'll see, it is showing us how, and then string, and then any. So string I'll just give any, so that it will check all the rows, and if there is any null value, it will simply remove or drop that respective row. So I will just check with the new data frame. So my new data frame name is df underscore any, and we'll just display that data frame. So we can see that now we have 1266 rows, and it has deleted all the null values whichever are there inside our data frame. So we can use this any string in this way. There is one more string which is all we can use for DropNa. So this all, what it does, so it removes the rows only if all the columns in the rows are null. So rows with at least one non-null value, it will be retained, and with all null values, it will be deleted with all string inside this DropNa. So let's just check with this all function. There are some minute changes only. So instead of any string, we will just display all string. Now we can see we are getting these null values because these null values are only they are appearing at least only once, but whole row or the complete row, it is not null. So in this situation with all string, if this complete row is null, then that row will get particularly deleted. Otherwise, the rest of the information that will get retained with this all function. So if you want to delete all the null values or all the rows which contains the null values at least once, then this DropNa with any string, it is beneficial for that business query. Now let's say we have this company type column, right? So for this company type column, I just want to replace these null values with any word, and I just don't want to apply this transformation to rest of the columns. So in this case, what I can do, I can use FillNa function which we have used earlier, and this time we will just use subset into that so that it will get applied to that respective column name. So the syntax for this is very simple. So df dot FillNa, and then null values, we want to replace those null values with any word, and we will give our respective column name as a subset here into square bracket and inverted commas. So company type, for this subset or for this column company type, replace null values with NA function using FillNa function. So let's just check now. First assign this transformed syntax or transformed values to our original data frame, and then just display that data frame, and we'll check if it is working or not. Okay, then where is our company type? See, for the company type, null values has been replaced with NA word. So now this is only for one column, right? So what if I want to apply this to all these values and to the complete data frame? So it's very simple. So we will just remove this subset and it will get applied to the complete data frame. So we'll just remove this subset. So it will treat that, or it will consider that we want to replace all the null values from our data frame with NA. Now we can see our null values are replaced with NA function, or sorry, NA word. So this is how this FillNa and DropNa functions work. So now let's say suppose I just don't want this column name, I just don't want this complete column because it is redundant for me and it is not necessary for my further analysis. So in this case, what we need to do is like we'll need to drop this column completely. So we will use the drop function again, and in that drop function we will simply just display that respective column name which we want to delete or remove. So df will be our data frame, df dot drop, and in that drop function we'll just simply just display, or simply we'll just add that column name which we want to drop, And now we will display that data frame. This will be our output, and we can see that that column has been removed and we don't see this city development index column, so we are getting the as expected result. So now next we will see about the joins. So to apply these joins, I'll just simply create two simple data frames with 3 or 4 values inside it. So the first data frame will be df1 and the next data frame will be df2. So to create a data frame, we will need that schema and the sample data. So this will be our schema for the first data frame. So our first data frame will contain the column, namely name, department, and age. And in that column, we will have these 3 values of John, Alice, and Bob. And next, we will similarly contain the second data frame. So second data frame will contain 2 columns, namely name and the city. And in this name and city, we will have these 3 simple datas, John, Alice, and Charlie, along with their respective cities. So now we can see that for data frame 1 and for data frame 2, we have name column common. So we will treat that name column as a primary key. So in this data frame, it will be treated as a primary key, and in this data frame, it will be treated as a second foreign key. So we can apply our conditions on this column because this column is common for these 2 data frames. So the syntax is very simple. We just need to display sample data. We just need to add sample data with this function, and then we'll add the schema, and we'll create the data frame with spark.create data frame. And in that create data frame, we will give our schema name and the sample data name. And similarly, we have done for df2 also, and we will now display both df1 and df2. So these are our output. As I told you earlier, our common column name will be name, so that we can apply different kind of joins on this and we can check the output. So first I'll tell you the syntax of that joins, and then I'll explain you how it is working here. So for example, firstly we'll check how inner join functions here. So I'll just create one new data frame so that I can check the output with that data frame. I just don't want to manipulate df1 and df2 which we have created. So the first data frame or the left data frame, I would want df1, and then I would like to join this df1 with df2, and the condition would be name as a common column name, right? So df1 dot name would be equal to df2 dot name, and then comma, and we'll simply then mention which join we want to use. So first we want to use inner join, and then I would like to display this new data frame which we have created for this inner join. So this is our output. So let's see how this inner join is functioning. So if we'll check df1 and df2, so this inner join, it will return the rows where there are matches in these both data frames. So if a row in one data frame does not have corresponding row into another data frame, then that entry will get excluded. So here, for example, we have John. In data frame 2 also we have John, and Alice also we have in both the data frames. So inner join needs to display only these 2 data entries, and as we know that this Bob entry is not present here, so simply it just need to exclude this Bob entry, and so that output of our inner join must be only these 2 entries along with their respective all the columns that need to be displayed in our inner join. So if we'll check our output, we can see that it is just displaying only 2 values, Alice and John, along with their department, age, and city. So this is how this inner join functions. So our next join would be inner join. The next join would be the left join. So the syntax will be pretty much same. So instead of this inner, we will just change it to left join, and then just data frame naming convention change. So I'll just give it as df underscore left. Now let's just check the output. So this is the output which is getting displayed here. So now we'll check how this left join functions. So with the left join, we can expect that it should return all the rows from the left data frame and the matching rows from the right data frame for those values. So if there is no match found in the right data frame, then it should just give the null values. So here, if we can see, this is our left data frame df1 and df2 is our right data frame. So for left data frame, it needs to give all these three entries, and for these three entries, it also needs to display cities. So if we can check, we have John and Alice here. So for John and Alice, they need to display both the department, age, and then respective cities. And for the Bob, we can see that it has department and age here. But in the data frame 2, we don't have the value of Bob. Instead, it is Charlie. So with the left data frame, it should display, or it should take all these three values and the respective values for those entries which are present in the data frame 2. So from here, it will take John and Alice city values, and then it needs to be displayed. So we can check, we are getting that same exact result which is expected. So John, Alice, and Bob, three entries from that left data frame with that department and age, and from the right department it has taken the cities as expected, and for the Bob there was no city, so it is just giving us the null values for the left join. So this is how this left join functions. And similarly, or on the contrary, the right join needs to be functioned. So instead of this left data frame, it should take the right data frame with the all values. So in the right join, it will take all these three values, John, Alice, and Charlie along, and for John and Alice we have entries in the left data frame also, so only those two entries will be taken from the left data frame, and for Charlie, department and age, that needs to be displayed as a null values. So we'll check if it is functioning as expected or not. Again, the syntax is very simple, so instead of just left, we just need to give string as right. So I'll just copy paste the syntax as it is, display just right. See, we can see here now it is giving us right data frame as it is, and for John and Alice we have entries in left data frame also, so those entries it is returning, and for Charlie we don't have any entries, so it is just displaying null values for the name Charlie. So this is how this right join functions. So the next one is full join. So we'll check how this full join functions. So instead of just this right, we'll give outer. Full join is nothing but outer join. So we'll just change data frame name. Now let's just check the output. So we can see that for this full outer join, it returns all the rows when there is a match in either left or right data frame. So if a row from either of the data frame does not have match into other, it will contain the null values for those missing entries, but it will return all the values which are present in df1 and df2. So the use case for this, we can say that it is useful when you when you want to keep all the data from both the data frames with the null also where match doesn't exist. So if you can see, this is our main data frame, right? So here it needs to give us all those four names, because John, Alice, it is common for both the data frames, right? So John, Alice, and then we have this Bob, and then Charlie. So these are our four entries which needs to be returned. And if there is no value, suppose for this Bob we have department and age, right? And then the city. Sorry, for this Bob we have department and age, but we don't have this value for Bob into right column with the city. So for Bob, it needs to give entry for the city as null value. So it will return Bob value also with the city null. And similarly, it will return the value for Charlie also, but for Charlie, department and age, those values needs to be null, but all those four values that needs to be displayed in full outer join. So we can see that we are getting all the four values: Alice, Bob, John, and Charlie, and rest of the values for them are the null values. Now let's try to understand what is union and union by name in PySpark. So in PySpark, these both functions are used to combine two data frames. However, they differ in how they handle the column names and the order. So first we will create two or three sample data frames. So now let's understand. So first we are creating this first data frame df1 by syntax spark.create data frame with data 1 and column 1. So the column 1 has two columns, namely name and the age, and we have created three sample values or three sample datas for this df1. Similarly, we have created df2, and in df3 what we have done, so in df1 and df2 we have the column names, namely name and then the age. But in df3 what we are doing, so we are taking age as a first column and then we are taking name as a second column. So now let's try to display these three data frames and try to understand how these two functions work. Okay, so these are our three data frames, name, age for these df1 and df2, and for df3 we have taken age as a first column and then the name. So now let's try to use union. So let's say suppose we will try to use union for df1 and df2. So what we will do here is we will create one more data frame, namely maybe df union is equal to, then we want to union two data frames, right? df1 dot, and we want to union this df1 with df2, and then we would like to display this new data frame with the union. So now let's try to see our outcome. So let's see here. Now we can see that our all these three entries, these three from df1 and three entries from df2, those six entries are getting displayed as expected with the first column as name and then the second column as age. So now let's try to use this union on df1 and then df3. So let's see how it functions. We'll see the outcome now. Now we can see that for df1 we were having name and age, right? And for the df3 we were having age as first column and then the name. But if we see the outcome, it seems like it is not getting displayed properly, right? Because three values we are getting name and age correctly, but for the df3 it is showing like age values in the name column and then the name values in the age column. So we can say that union function, it combines the two data frames by stacking them row wise, but the requirement for this would be the two data frames must have same value, it needs to have same column order and the same data types. So if the column order differs, union will not function correctly. So what we need to do in this situation? So in this situation, union by name comes into scenario. So let's try to apply this. We will take the same syntax, but instead of union, we will use union by name. So let's see if it is functioning properly or not. Okay, union by name has no attribute. I think we are doing some syntax mistake. Let's do it again. Okay, it was a syntax mistake. And then df1, we want union by name with df3. Now we can see that even though df3 had age as a first column, right? Age as a first column and then name as a second column. If we are using union by name, it is categorizing it properly and we are getting name values in the name column and the age values in the age column. So we can say that in union by name, it is similar to union function, but it matches the column by names instead of their position. So the requirement for this union by name, we can say that both data frames must have same column names, but order can be different and it does not require the columns to be in the same order. So if we can see that even though the columns are not in the same order for df1 and df3, it is giving us the result as expected. Now let's try to understand some date function from PySpark. So first we will display our original data frame and if we can check if we have any date column or not. Okay, it seems like we don't have any date column. So what we can do is like we can add one new column with the current date. So to add a new column, again, as we know that we have WithColumn function for that. So with WithColumn, I would like to add a new column with new column name as current date. Okay, so this would be my new column name, comma, and to add values of a current date in that new column current date, we have current date function. So we'll simply use that function, and once this syntax will get executed, I would like to modify my existing data frame. So I'll assign df equal to and then the syntax to add a new column with current date, and then we will display our new column we will display our existing data frame. So now let's see if we have current date or not. Okay, so we can see that our query has been executed properly and we are getting new current date as a column. So let's say suppose now I would like to add a new column again with any random dates. So for example, we will take year as 2023 and I would like to add a new column with any random dates from the year 2023. So again, we'll see how we can execute it. So this is our original data frame on which we want to work. And again, to add a new column, we have with column function, and then we'll give our new column name here. So let's say suppose my new column name I want as last training completed. So this would be my new column and then comma, and again to add any random value we will use function as expr. So with this expr function, again now we would like to create any random date, right? So to construct a valid date from the year 2023, we have one function as make underscore date. So with this function, we will try to create one new random day. So for this, we have chosen year as 2023, right? So first we will give our year as 2023. Then we need to create any random month for that respective date, right? So for that, what we will do first, we will use floor function, because floor function, it will round it down to any to respective whole number, so that will not get any decimal number here. So for that we will use floor function, and in this for floor function we will use rand function that will convert a random month between 1 to 12, right? So we will use rand function, and this function we want to create from 1st to 12th to 1st, like 1st, like January to December. We want any month whole number we want for that whole any month. So this would be, so first we have created year, now this is our month, and after month is done, now we need to construct a date, right? So again I'll use floor function, and again I'll use our and function to generate random number, and we would like to generate a random number from 1st to 28. I'm just taking 1st to 28 because February has no values or no dates till 30, right? So to be on safer side, I'll take from 1st to 28 here. And let's see if it is getting executed or not. So okay, so we have this syntax, right? And then once this syntax get executed properly, we would like to modify our data frame, right? So let's hope. Okay, so what is it saying? A column of or a function. Okay, again syntax error. It needs to be plus sign. It is executed successfully, but we need to see the values. Okay, so we can see that we have new column as last training completed, and we have values from the year 2023 with the random generation of any date or any month. Okay, so it seems like it has been executed successfully. So now let's say suppose I would like to calculate the dates since the last training completed. So this is our last training and this is our current date, right? So I would like to calculate the number of days between these two dates, and I would like to display it in a new column. So to execute this, we'll see how it works. So df and again with column, because we like to display that difference in the new column, right? So let's say suppose my new column, I want days since last training. Let's say suppose this is my new column, then comma, and to calculate the difference between two dates, we have a function named as date difference. So this date difference will calculate the difference between two dates. In our case, those two dates will be last training day, last training completed, and the current date. So date difference, and in this date difference we would like to display those two columns, right? Or even if we don't display that column current date, we can take that function also to display that current date, and then comma, and then the next column would be column last training completed, and we need to give that column name into inverted commas. So this would be my syntax, and then we would like to modify our current or existing data frame. Again the same display function. Let's hope now it will work properly and we'll get the difference between two dates. Okay, we can see that now we are getting the difference between last days completed to the current date, and we are getting the exact days with the difference of last training completed and the current date. So we have date difference function for this to calculate the days between two days. Now let's say suppose I want to add 30 days to one of my columns. So here we will take last training completed. So I would like to add 30 days to each of these columns values, and I would like to display that after 30 days date into my new column. So for this what we can do, so we will use WithColumn function, and let's say suppose for the new column name I'll have my new column name as add 30 days, and then comma, and to add I suppose in this case we want to add 30 days, right? So to add these dates we have the function as date add. So in this date add we will use the column which one we decided, last training completed. So we'll use this column name into inverted commas, and then we want 30 days into this, so we'll write 30 here. and we'll modify our existing data frame and then we will display it. So the syntax is very simple. Again, we will use with column to create new column here, and we'll use date add function to add these 30 days, into our column last training completed. So let's try to execute it. Okay, so we have this new column, we can see here, right? Add 30 days. And this was our, let's say suppose for the first entry, this was our training completed. And into that, it has added 30 days more. And then it is giving us that respective days, which will be after the 30 days of that last training completed. Okay, so now the next we'll see, let's say suppose I would like to extract, we'll take this column last training completed, and in this, from this column I would like to extract exact year, month, and then the day. So to extract these three different values here, those are year, month, and date, into new columns, we'll try to see how it functions. So again, df dot with column, and to add to have a column with all the years for all the entries, what I'll do, I'll give that name or new column name as training year, comma, then to extract that year we have year function in PySpark, and year, and from which column name you want to extract that year, then we, from the column last training completed, I would like to extract it. So I'll give this column name here into inverted commas. So this would be for my year to get extracted. So similarly, we will try to extract month and then the day. So we have for the year we have this year function. Similarly, for the month we have month function, and to extract that respective day, we have day of month function in the PySpark, and we'll assign this to our existing data frame. So df equal to all the syntaxes, and then we will try to display and check if we are getting new columns with those extractions or not. Okay, so we are getting training year and not month and day. Okay, so here we have done one mistake. So training year, we are assigning it to the new column name training year, right? But we forgot to add a new column for training month and training date, right? So we will need to display those new column names here. So we have done the changes, training month and training day, and now let's see if we are getting it or not. Okay, so we can see that it is extracting training year, month, and day properly, because this was our day. This was our date for the 8th row, and it is extracting, okay, day was your 12, month was December, and the year was 2023. So it seems like it is extracting the year, month, and the days properly and exactly. So these functions, like these functions, year, month, day of month, it will basically allow you for the aggregations or the filterings based on your respective year, month, and a day. Now let's try to look into array and explode function. So for that, first we will display our original data frame. So this one is our df data frame, but we can see that none of these values or none of these columns have comma separated values. So what we can do here is, like, we can create a new column where each candidate has multiple skills as a list. So basically for this we will need to create an array, right? So we would like to add one new column here, which with name as skills. So we will add one new column here with skills column name, and in that skills column name, for the each rows we will have an array which will shows a list of arrays. So for this we will need to use array function, right? So let's see how we can use this array function. So for this we will use new data frame df. Sorry, we'll use the existing data frame only, df dot again with column, and I would like to have new column with the name as skills, then comma, and we would like to create comma values, like that means array, right? So for that we have function as array, and in this function, let's say suppose skills, I would like to add Python, SQL, and then the machine learning. So for each row I would like to have these three values in that respective array. So to add these three literal values, we will need to use lit function, because these are literal values, right? So first literal value would be maybe Python, then again comma, then what we have decided, the next one was SQL, and the third value was machine learning. So this would be my syntax. So we are adding these three literal values as an array into a new column which will name as skills. So we will modify our existing data frame accordingly. So let's see if we are getting array with these three literal values or not. Let's see now. Now we can see that we have a new column with these three values. So now we would like to use explode function, right? So how this explode function will work exactly? Okay, so we can see that we have these enrollment IDs, right, as a primary value. So for each enrollment ID, we have these three list of values in each array, right? So with explode function, what will happen? So for this, let's say suppose for this ID 31203, it will create three values. So one value will be with the skill Python, then the next second value will be with the skill SQL, and then the third value with the machine learning. So we can expect here for each enrollment ID, we need to create three new rows with the explode function. So here what will happen, we'll have 32403 enrollment ID, and we will have three entries for this enrollment ID with the skill Python, SQL, and machine learning. So this is how this explode function will work. So now let's try to execute this. So let's say suppose I would like to create a new data frame. I'll take the new data frame name as df underscore explode, then df dot with column. So I would like to add a new column instead of modifying it into existing column. So I'll have new column name as exploded, maybe explode skill, then comma, and then I'll directly use this explode function which is available in PySpark. And in this explode function, we will just give the column name which we want to use. So our column name is skills, right? So this column name we will give here into inverted commas, Alias skills. And then now let's see if we are getting the output or not. Then you will use display function. So I think it will give error because I have done typo mistake here. So this is our new data frame df underscore explode, and in this we can see that earlier we were having these skills as a list of values as an array, right? But now it is explode function is working properly, and it is giving me three different skills into three values for each enrollment ID. So we are now, let's try to see group by, collect list, and count function. So this is my original data frame. So let's say suppose with this data set, I want to analyze how experience level vary across the different enrollment categories. So in this, what we need to do is, like, we have this enrollment category as with the column enrollment enrolled university. So in this we have category as full-time course, part-time course, or new enrollment values, right? So I would like to analyze this enrollment university column across with these different categories with the experience. So for the experience, we have this column as experience, right? So for this, what we will need to do is like we'll need to do two transformations, right? So the first one we'll see now. So the first one is like we would like to group the candidates based on this enrolled university and then collecting their experience levels. So to group these enrolled universities, or we will use group by function with this enrolled university column, and to collect their experience levels, we will use this experience column with the function collect list. So now let's see how we can use this group by and collect list with for this experience by university enrollment analysis. So for this, what we can do, first, we will use group by function. So with our data frame, we'll use group by function on enrolled university column. And then we need to use collect list, right? So for using this collect list, we will need to aggregate this function, right? So we will use this agg function which we use for the aggregation, and in this aggregation we will use collect list function, and we will use this collect list function on experience column. So we would like to use this function on experience column, and I want this aggregation with the new column name. So for that, we will use alias function. And let's say, suppose instead of experience, I would like to use alias as experience list. Experience list. And for this, I'll create new data frame. Let's say, suppose df collect, and then I'll assign this transformed data frame to that, and then we will check if this new data frame is giving us the results as expected or not. Now we can see that this is our new data frame df underscore collect. So it is using group by on this enrolled university. So we are getting this full-time course, no enrollment, part-time course, and we have some values which were earlier blank, which we converted to not applicable in our earlier transformation. So we are getting these four values, and it is giving us experience list, which is not getting the name is not getting properly executed or displayed. So let's modify this name. So now we are getting this experience list for each of these enrolled universities. So to get this experience list, we have used aggregation function, which is collect list. So for full-time course, we have the experience of 9, 3, 13, 2, and so on. So this is how this group by and collect list function works. So now let's say, suppose I want to count the candidates in each of this in enrolled university category. So we have this enrolled university category, right? So I would like to count the candidates for each of these category. So for this, we'll need to use the count function, right? It will be very simple count function. So df, and first we would like to group it by, because for each enrolled university we want this count. So we'll need to aggregate this enrolled university because we have these four categories for this. So again, we will use this aggregation function, oh sorry, group by function on enrolled university. And after group by, we will use this count function. So this syntax is pretty much simple, and we will assign new data frame name. Let's say, suppose df underscore count, and then I would like to display that count into my new data frame. Now let's see if we are getting the expected count or not. Okay, so now we can see that for full-time course we have 435 values. For the no enrollment we have 1519, and part-time course we have 144 values. So this is how we can use count function. And now let's try to understand pivot function, which is available in PySpark. So let's first see our data frame and how we can implement pivot function into that. Okay, so this is my data frame. So let's see, let's say suppose a business wants to analyze the training hours. So business wants to analyze these training hours across the university enrollments and the gender. So we would like to use these training hours and want to analyze these training hours across these enrolled universities and the gender. So basically we'll need these three columns: employee gender, then enrolled university, and then the training hours. So to implement this business or to check this business analysis, what we will need to use? So first we will need to categorize our data with the enrolled universities. The categorize means group by. So first we will need to group our data or group our candidates by enrolled universities, and then we will need to use pivot on this employee gender. And after using this pivot, we'll need to analyze the average of training hours for this enrolled universities and the gender. So for this, we will need to basically implement this pivot function, right? So if we'll see this pivot function is mainly used to transform the categorical values into separate columns to make it easier to analyze and compare the data across the different categories. So here we can see that we need to use these categorical values. We need to use this training hours for the training for the employee gender and the enrolled university. So we can say that we can use pivot function here. So by using this pivot function, what it will do for our data analysis, then first it will improve the readability. So and then it will be better, it will be easier for us to have the better comparison, and along with that better comparison we will get the aggregated insights also. So now let's see how we can implement this pivot function. So let's say suppose I'll create new data frame for this. So I'll give the name as df underscore pivot. Then first we have decided that we will use group by function on our enrolled universities, right? So first we will group it by our enrolled universities. Then we will use our pivot function. So we have directly pivot as a function in PySpark. So pivot on what? Then we want pivot on employee gender. So we will give this column name here. And then after pivoting, we would like to aggregate. And aggregation by what? Aggregation, we want average values of training hours. Average values of these training hours. So average of, then the column name, training hours. So this is the syntax, and then we will display our new data frame. So the syntax is pretty much simple. We will group it by enrolled university, then we will use pivot function on employee gender, and then we need aggregation with the average of training hours. Now let's see if we are getting pivot table as expected or not. Now we can see that we are getting pivot table, which we get in Excel also. So enrolled university, we have 4 enrolled universities. That means 4 types of enrollment, which is full-time course, part-time, no enrollment, and we have some not applicable values also. And in gender also we have male, female, and the other section and unknown values. So with this we are getting training hours. The aggregation, that means the average of training hours for these values. So this would be my pivot table. So it will be better for us to analyze some insights. So for example, we can see that how candidates are there in full-time course and what are their trend, and then how much we have male candidates who are receiving some higher training hours. Then we can say how many candidates are there with the no enrollments and so on. So it will be better for us. So many times we choose pivot table for such kind of complex analysis. It will give us the table which makes our life easier for the analysis. So now let's try to understand how this when otherwise function works. So let's try to see our original data frame again. So we have this column as relevant experience numeric, right? So if that respective enrollment ID or if that respective employee has any kind of past relevant experience, then we are displaying this value as 1, or else we are displaying this value as 0. So let's say suppose I want to create one new column, and in that new column I'll give uh, I'll give some new name for that new column. And for this, if this employee ID has relevant experience, then I would like to display that value as yes. Or if that value is 0, then I would like to display that value as no. So for this, we will use when otherwise statement. So this is nothing but, or this is similar kind of if and else statement, which we often use in different kind of syntaxes or in different programming languages. So let's see how it functions. So this is our data frame, right? Df dot. Then we would like to utilize our column, which is relevant numeric experience, but we want new column name here, right? So our new column name, let's say suppose job change status, then comma, and then we will enter our when otherwise condition here. So when our column value, column relevant experience numeric value is equal to 1, then I want my new column entry as yes. Otherwise, I would like to display that value as no. So the syntax is quite simple. So we are creating new column with column function, and we are using this if else, that means when otherwise condition. When this column entry is yes 1, then we want new column entry as yes, otherwise no. Now let's see, we can see that we got this job change status column with yes and no values. So let's check this no condition or cross verify it. So we can see that for this relevant experience is 0, so we are getting that value as no. So we can say that our syntax or our function is getting executed properly for this when otherwise function. Now we will try to explore two most commonly used window functions in the PySpark, and those are rank and the dense rank. So these functions are used for ranking the data within the partitions, but they both handle these partitions in a very different ways. So by the end of this execution, you will get the understanding of how these both functions are different from each other. So for this, what we need to do is like we need to import the functions rank and dense rank, and along with that we need to import windows also. So if you remember at the start of the video, at the start of this coding, we have imported all the functions using pyspark.sql.functions import star. So now we are left with the windows function to get imported. So we will just import this function at the start, and then I'm going to create one new data frame for the simplicity. So our data frame name would be df underscore demo, and we will create it with the syntax spark dot create data frame and then the column names and then the values. So our column names namely contains employee ID, then the name followed by the training duration. And for these three columns, we have created 6 sample values for these employee ID, name, and the duration. So now let's try to execute this. So this is how our data looks like. So first thing first we'll need to define the window specification. So we can define it as window spec is equal to then window, and after the window what we will do is like we will order our data in a descending order of training duration. So this will be our column name, which we will give it here, and we will order it by in a descending order. So this will be our window specification, where we are defining that okay, we want our data in such a way that we will order this data into descending order of training duration. So this is how we have defined our window specification. Now we will see how we can implement rank and dense rank function. So our data frame name is df demo is equal to, again we are going to use this df demo. Then we have this with column function, and with column I'll add one new column, which and the name of that column will be rank, and in this rank I'll just simply use rank function over our definition of Windows specification. So this was our Windows specification, which I'll give it here. So depending on this condition or definition, it will rank our data. And now let's try to see how it functions. So we can see that we are adding a new column here, right, of the name rank. So this rank function, it will assign a rank to each employee based on their training duration. So what does it mean? So employees with the same training duration will share the same rank, but the next rank will be skipped. So now let's see here. So Alice and Bob has same training duration of 50, right? So instead of rank 1 and 2, we are displaying the rank 1 for both of them because their training durations are same. Similarly, for David and Eve, their training duration are same, so we are assigning the same rank for them. So in this case, what is happening? So for 50-50, both training durations, we have assigned the value 1 and 1, right? So now one rank is done. So now the next rank is 2, right? So for the Charlie, it should assign the value 2, right? But instead of 2, it is assigning the value as 3. That means rank function is skipping the value of 2 here, and it is assigning the next value to the next employee. So here also ideally 4 and then 5, right? But as they have the training duration same, it is assigning 4 and 4 value here. But for the next employee, instead of 5, it is assigning 6, because ideally it would have been 4, then 5, and then 6. So instead of 5, it is assigning the value as 6 here. So this is how this rank function works. Now let's see how this dense rank function works. So the syntax, it would be same for this. So instead of rank here, we will just change it to dense rank. Dense underscore rank, and then this is the function. No. Okay, so we want this name as rank, and we would like to add a new column as maybe let's say dense rank. Okay, so now this problem has been resolved with dense rank. We can see it here, right? So I have explained you how it has assigned 3 value here instead of 2, but that query has been resolved with this dense rank. So now Alice and Bob has same training duration. So it is for both rank and dense rank, it is giving rank as 1, but for the Charlie, the training duration is different, right? So rank function, it will assign the value as 3 here, but the dense rank, it will assign the very next value here, so it is assigning value to here. So next, for David and Eve, we have training duration 40. So next incremental value taken by rank is 4, but for dense rank it has taken the next incremental value as 3. Again for the rank 4, 5, ideal value would have been 6, so it has given, rank has given 6 value here, but dense rank has corrected it and it has given the next incremental value 4 here. So this is the difference between rank and the dense rank. I hope I have simplified it for you in a simpler way. So this is how this rank and dense rank function works. Now let's try to understand this PySpark sum function. So we will import this PySpark sum function from the functions, and we can see that we are aliasing it here just to avoid the confusion in case if you want to use the standard function sum, which is the standard function sum which is available in PySpark. So just for the better clarity, we are using alias here for this function. So now we will try to use this function on our original data frame. So this was our original data frame on which we were working on. So for this also, first we need to define our window specification for the cumulative sum based on their order of city. So I'll just copy paste this code and I'll try to explain you. So first we are just defining our window specification as window spec, and we are using order by city here. So that means that we are going to do cumulative sum based on the order of city number. So this is our city column and it will get ordered into ascending, and we will use that as a window specification. So now next we are defining a cumulative sum of training hours. So we can see that we have this training hours column here. We have so many columns now. Where is training hours? Okay, this is our training hours column. So we are going to use this training hours column. So for that we have used function .WithColumn, and now we will create one new column here, and we will create this new column, and then our function which is PySpark sum on which we will use on training hours over the window specification which we have defined. So this PySpark sum which we used on training hours, so this will compute the sum of these training hours, and this over specification windows, it will tell the PySpark to apply this operation over the window which we have defined. In this case we have defined order by city, so it will tell the PySpark to use this condition. So this cumulative sum, this will what it will do, so this cumulative sum means that for each row it will sum all the previous rows in the data set along with the sorting by data. So let's see how it looks. So I'll just, let's say, suppose, okay, let's just try to execute it. Okay, so now we can see that first we have defined our window specification, then we have applied our cumulative sum for the training hours, then we have so many rows here, right, and columns here, right, so it is becoming difficult for us to analyze. So we are just selecting few columns here which are city, training hours, and then the new column which we have created, and in that we are just ordering our all the selected values by the city column, and then we are just displaying it here. So cumulative sum, we can see it here. First we have city 10, right, city 1. So for this city 1 we have two training hours value 18 and 9, which sums to 27. So this cumulative training sum hours for this city 1, it is getting displayed as 27, 27 for these both two values. So next city is of city 10. So we have so many values for this city 10, and these are their respective training hours for that, and the cumulative sum for these training hours is 921. So for each of these cities, it is displaying the cumulative sum as 921 in our newly created column. So similarly goes with the city is equal to 100, then 101, 102, and so on. So this is how this cumulative sum functions. Now let's try to understand user-defined functions. So UDF in PySpark is basically a way to create custom functions that you can use to process the data frame columns. So while PySpark provides you many built-in functions for the data transformation, maybe like sum, average, count, and so on. So sometimes the built-in functions are not enough for the specific needs which are demanded by the business. So in such cases, you can define your own function by using Python logic and apply them to the columns in your data frame. So if we say that, or we can check why do we need these UDFs. So first one, we can say that it is better for the customization because UDF allows us to create custom transformations that are not available in this PySpark's inbuilt functions. Then we can say scalability because although UDFs may be slower compared to using built-in PySpark functions, they can be applied on the large data sets in a distributed way by maintaining the scalability of their Spark. So let's say suppose first we'll see which functions do we need. So we need to import UDF function from the functions and we need integer type from the types. So after importing these functions, I have created one new data frame on which we will be working on. So let's try to execute this data frame. Okay, so we forgot to display this data frame. Dot display. So this is how our data or data frame looks like. So imagine that we are working with this data set which contains this employee information, which includes experience and education level also. So along with this information, however, we can say that this experience column, this column contains the values which are in textual format. So to perform some analysis or the comparisons, maybe comparing employees' experience and so on, so we need this column to be numeric. Therefore, suppose therefore we'll need to convert this experience column into a numeric format to simplify the data analysis, right? So what we can do in this situation? So to solve this business problem, we can create or we will use UDF to convert this experience column, which contains text like format like 1 year, 3 year, and so on, into a numeric format by representing the years of the experience. So this will allow us to perform further analysis also for example, sorting, filtering, or aggregation on the data based on the years of their experience. So now let's see how we can write this code. So now as we have this code, now we will create one or we will define one UDF function. So for that, what you can do, you can say def, then we will convert we will use the function name as convert experience, and then here we will use the column name experience, and then the colon, and then enter. So in this we will write if statement. If experience is equal to never, then let's say suppose return me 0. Else if year in experience then return integer value of experience and split this experience value and take the index 0, that means a numerical value 1, 3, 2 and so on. So this return will extract the number. Let's say suppose from 1 year it will just take out one number, it will extract that one number. Else we will say else return 0. So we have defined our UDF function like this. So this function we will use to convert the experience column into a numeric value by representing years of experience into it. So if we understand the function logic of this, so if the experience is never, then it will return 0 because it means it has that particular employee has no experience. Then if the experience contain the word year, then we will split the string by space and we will just take the index 0 value into it. So 1 year, then 1 will be index 0 and year will be index 1. So we will just take 1 from this and we will extract that numerical number here. Otherwise return 0. That means if the format is not recognized, we will return 0. So this is a very simple and basic UDF function we have defined. Now let's try to execute further queries for this. So now let's say suppose what we will do, like we will register the function this convert experience as a UDF by using UDF function, and we will specify that this function will return an integer value. So for this what we can do, let's say suppose we will return it as convert UDF, then we will use this UDF function, and in this UDF function we will use our defined UDF and we will state that our return type must be integer. So here we will say integer type and we will take this function. So this is how we are registering our function convert experience as a UDF using this UDF function, and we are specifying that our function will return an integer value. So now this is how we can register our UDF. So now we will try to apply this UDF to create a new column experience year in our data frame. So in this data frame we will try to add one new column named as experience years. So for this what we will do, our data frame name is df UDF, so we will take that same data frame name and then df UDF and we will use WithColumn function, and in this we will create one column namely experience years, comma, and then we will use our convert UDF function, and in this convert UDF function we will again use our data frame df demo with the column experience. And then just simply display this data frame. So here what we are doing, we are just applying our convert UDF to the experience column. So now let's see the output of our data frame, how it looks. So what is it saying? Experience is not defined. Okay, so we forgot to add inverted commas here. Now let's check again. Okay, we need to give df UDF here. hope it works now. Okay, now we can see that it has added one new column, experience years here, and it is showing us the proper years here, 1, 3, and 2. And if we don't have any experience, then it is showing us experience years at 0. So this was just one basic simple example which by which I have tried to show you how this UDF works and how we can create the function and how we can implement those functions afterwards into our data frame. Now lastly we'll see how we can export the data. So now let's say that you were having the data earlier and you have transformed that data, and now you have saved that transformed data into one data frame, and now you want to export that data frame, or you want to save that data frame as a table into your DBFS. So for that, what you can do is like you have write command. So df is our data frame. Then what we can do is like df dot write dot, then we need to display the mode. So we have 4 types of mode: overwrite, error, ignore, and append. So we will see it one by one. So first we will see overwrite mode, and then dot csv, because I need to save my file as csv, and then I'll give the dbfs file path. So my dbfs file path will be file store slash tables slash into table. Let's say suppose I want to create one folder, so maybe my folder name is full course, and in that folder I want to save my file as maybe full csv. This is my file name which I want to save, and dot format dot csv. Now let's see how it works. So now it states that this query has been executed successfully. That means that our file has been saved as expected. So now let's see under the tables. Now we can see that our new full course table has been created, and in this full course table I have this file as full CSV which we have created right now. So it has created all the files which contains main data and all the logs also. So now we have written this code with the mode as override, right? So apart from that, we have 4 types of modes. So we'll see one by one how these modes functions. So in overwrite mode, what happens is that Spark, let's say suppose this is your file, right? This is your full CSV file, and you have one more file as full CSV into your DBFS. Okay, so these 2 file names are same. So in overwrite mode, what will happen when Spark will try to write this query, or sorry, write this file into your DBFS or into your file store path. So in overwrite, Spark will delete the existing data from here. It will delete this data, and it will replace this data with the new data, which will be, in our case, which will be this data into your DBFS. So this is how this overwrite mode functions. The next mode is append mode. So in append mode, what happens? Suppose you have this file here, right? So you have, let's say suppose you are going to store your file here. This is your original file, and you have one more file with the same name which is stored already here. So in append mode, it will not overwrite this already existed file. So instead what it will do, it will just keep adding those files. So we have already full CSV file here, right? So this file will get added here as a new file, but this original file, it will remain here as it is, and it will add one more file. So basically it will append the file here. So this is how this append function works. Then the next function is error function. So in this case, let's say suppose again the same scenario, we have one we have one file saved here. That file name is also full CSV. We have this file also full CSV, and now we are trying to write this file here. But now the Spark will say that okay, we have one file already stored here, but we are again trying to save same named file here. So instead, what it will do, like it will not save this file over here, and it will throw one error which will say that you have, it will basically that error, that it will throw one error. So it will say somewhat like you already have already your file already exists at that in your storage account, and it will not allow you to save this file into your storage system. So this is how this error function will work. And the last function is this. After the error we have last function ignore. So ignore will also function same like error, but error function will throw you one error. Ignore function will not throw any kind of error. It will just simply ignore everything. So it will not save your file here. That's the main thing, which error also does. But error will, along with not saving this file here, error will give you one error message, but ignore will not give you any error message. So this is how our all four modes work, I can say that. So now we have saved our file as .csv, and we have exported that data as .csv format. So we have more formats for that. Along with CSV, we have Delta format, then we have Parquet format, then we have JSON, Avro, and ORC format. So for example, we'll try to execute, or we'll try to save this data with maybe Delta format. So what we can do for that is df dot write, then dot format, and here instead of CSV we will display, or we will write, we want to save our file as into Delta format. Then we have mode. In mode we will display, we want to append it and then save. And in save, let's say suppose we'll give this path but with new folder name and the file name. So let's say suppose our file name I want is maybe full delta, and in that I want to save the file as maybe delta save. This will be my file name. Now let's try to execute this query. So now it has been executed successfully. Now let's hope we will get it. File store, then tables. Okay, in tables it has created one new folder, and in that folder we have this delta save, and it has created delta logs also, and we have files also. So similarly we can save the file as Parquet. So instead of this delta you need to write Parquet, or if you want to save it as JSON, then JSON, Avro, or ORC, whatever you want to have. So I'll just briefly explain these formats. So this delta, this is basically built on the Parquet. So okay, let's try to understand the Parquet format first. So a Parquet format is a columnar storage format which is known for its high compression and the performance in this big data analytics. So it basically enforces the schema, and it is ideal when you have large scale data processing. Though it is not like this format, it is not human readable. It will make it best for the suitable for this analytics world, because it is better, or it will be beneficial for the big data analytics which contains terabytes of data. So then the next format is Delta format. So Delta format, it was basically built on the top of the Parquet format. So Delta, like, it supports the ACID transactions, schema evaluation, and time travel. So it's great for the real-time data processing, and large scale analysis, especially in delta lakes, but it introduces some kind of overheads for the small data sets. Then similarly, we have other formats like JSON, Avro, and ORC. So JSON is a flexible, human-readable format, which is ideal for the semi-structured data. While it's excellent for APIs and web applications, we can say, it's basically inefficient for the large data volumes, and it lacks the schema enforcement by limiting its use in large-scale data processing. So in short, we can say that if we want to save large amount of data, then we need to prefer Parquet or Delta Lake type format. And if we have some medium kind of data on which you are working, then CSV format will be better for you to export the data. That's it for the day, and thank you so much for sticking with me throughout this full course on Databricks using PySpark. I hope you now have a strong foundation to leverage the PySpark for big data processing in your projects. So if you have enjoyed this course and found it useful, then don't forget to hit a like button and subscribe for such kind of more in-depth tutorials on data engineering, analysis, and business intelligence. Also, feel free to leave any questions or the feedback in the comment section below. I'll be more than happy to help you out. And lastly, stay tuned for the more content, and good luck with your PySpark and Databricks journey. And until then, keep crunching the data. Thank you.